Yes, it's that time to start. I think we're reasonably on time. And in these lovely cool premises. So it's very nice. It's nice to be here. My name is Nitin Pandit. I'm the director of the Ashoka Trust for Research in Ecology and Environment, or short form, ATRE. So I'm happy to be here as we kickstart something. I'm going to ask Dominique if he would first start the process off.
Good afternoon, everybody. I'm Dominic McAllister, the British Deputy High Commissioner. I didn't have too far to go, so I apologise for being a little bit late. I just had to come downstairs. The challenges that you are kind of covering today are really interesting challenges, I think, for India and also for the UK. We are doing an incredible amount on the environment here in India. We're working very closely with research institutions to try to make sure that research is being done on issues of environment. We have the Newton Baba program, which is a £400 million program partnership between India and the UK. And a lot of those programs are on research. Some of the interesting research projects that are going on in our neighborhood here are to look at groundwater and to see kind of what sort of sustainability that has over the longer term. We've also looked at the monsoon, trying to map it and work out kind of where the monsoon is going to fall in any particular year and in how much, so that farmers can choose which crops that they should grow for that period because of the water that they're likely to have over the period of that year. Also, kind of on the more practical side, which is kind of looking at Bangalore and how Bangalore is becoming a sustainable city. We have been working very recently with the government here on electrical vehicle implementation. Karnataka is the first state in India to have an electrical vehicle policy, and at the moment it's starting to roll out electrical vehicle charging points across the city and encouraging the adoption of electrical vehicles with public service. So we're working very closely with the government on that strategy because it is an important strategy, and I think kind of kickstarting that industry is key to ensuring that sustainability kind of happens faster than it can be kind of at the moment. So lots of interesting things happening. I won't talk for too long. This is going to be really interesting. I was very excited kind of when I heard that you were coming, and I'm very pleased that you've managed to come down to the British Council from a packed program that you're organising up at ATRE. But I look forward to the afternoon activity. Thank you.
Thank you so much, Dominique. I'll maybe say just a few words to start off this program. Just so that you know, some of you may not know ATRE as an organization. So a couple of words on that. ATRE is an organization that, as its name says, does research in ecology and environment. We have two major parts of research that we do. One is looking at essentially the natural systems, and the second part is to look at livelihoods, because human interactions are critical to conserving and working with towards sustainability of these systems. So in effect, we have researchers here and in about 6 community conservation centers across India, and we've been around for about 20 years doing research in this area. One of the newer areas of research that we're looking at is in the area of health. And when you say health, I suspect the advances in the areas of health, whether it's human health or environmental health, are just going in leaps and bounds. Looking at it from different perspectives, therefore, becomes very important. And what we are trying to do, therefore, in this session here today is to bring together people who offer those different perspectives. This is to try and see where the field is going when we look at it not only from small local perspectives per se, but as to how overall at a planetary scale, at the global scale, how the issues regarding health are progressing, or what are the issues of concern, and what are the things that we as citizens need to be looking at and being thoughtful about. So in order to do that, we've brought a number of researchers here together, people who've contributed substantially in their fields. and especially with the keynote speaker that my colleague Abhi Vanak here will be introducing formally. To bring Abhi on, Dr. Abhi Vanak is a researcher, a senior fellow at ATRI. He's at the Center for Biodiversity and Conservation. He's the DBT Wellcome Trust India Alliance Clinical and Public Health Fellow. Is that right? Okay. All right. Okay. All right. I tried very hard to do an acronym on this one, folks, but I'm sorry, I just didn't manage it. So he has a PhD from the University of Missouri and a master's from the Wildlife Institute. And so with that, his areas of interest, zoonotic, infectious, and emerging diseases. A fascinating area which looks at the interface between human health and ecosystem health. He also has done a tremendous amount of research in invasive species and the ecology of human-wildlife interactions. So with that, Abhi, hand it over.
Thank you very much. So it gives me great pleasure to welcome and introduce Professor Sir Andy Haynes. It's a very long list of distinguished components. I will not delve very deep into this. I'm just going to give you very brief snippets of Professor Haynes' bio. So Sir Andy Haynes is a professor of environmental change and public health. He also holds a joint appointment in the Department of Public Health, Environments and Society, and in the Department of Population Health at the London School of Hygiene and Tropical Medicine. Previously, he was also the director and before that, the dean of the London School of Hygiene and Tropical Medicine. He has been a member of a number of major international and national committees, including the MRC Global Health Group, of which he was the chair, and the MRC Strategy Group. Professor Haynes was also a member of the WHO Advisory Committee on Health Research. He chaired the Scientific Advisory Panel for the 2013 WHO World Health Report on Research for Universal Health Coverage. In 2014-15, Professor Haynes chaired the Rockefeller Foundation Lancet Commission on Planetary Health and also co-chaired the development group for the Health Knowledge Action Network for Future Earth. In recent years, his research focus has been on the effects of environmental change on health and the impact of policies to adapt to or mitigate these changes. Today, he's here as the second Indian Academy of Science Springer Nature Chair. I invite him to deliver his keynote lecture on planetary health, linkages between global environmental change and human health.
Well, thank you very much, Abby and colleagues, for that very kind welcome. It's a great pleasure and a privilege for me to be here this evening. I'm at the end of a 2-week lecture tour around India. It's been a great experience. I've met lots of wonderful people doing fantastic research. But what I'm going to talk about this afternoon is to talk about some of the work we did with this Rockefeller Foundation Lancet Commission. The commission was set up, funded by the Rockefeller Foundation, but initiated by the Lancet Medical Journal, which many of you will know. It's probably one of the most prominent medical journals in the world. It's a very unusual journal, and that it takes a real interest in some of the cross-cutting issues that affect human health. It's not just biomedical. It also looks at the bigger picture. So when I heard about this name, Planetary Health, I had some doubts about it. I had some concerns about it, partly because I wondered whether people would feel, because these changes are going on at the global level, therefore there's nothing that individuals could do. And there's a danger of taking that away from using this term. But the conclusion that I want to come to, which I'll lead up to, is that indeed individual action can make an effect. Of course, we do need to also influence governments as well. So the definition really was very simply and distilled down into a nutshell was there. I won't read it out for you, but it draws your attention to the fact that ultimately the health of human civilization does depend on natural systems of our planet. And we've often lost sight of that, particularly in biomedical research. And when you look at a lot of the publications, they kind of assume that human health will just go on improving as it has in the past and don't take into account the very real constraints. So this slide is not to read in detail, but I just want you to absorb the sort of patterns, if you like, because I think it's quite an interesting slide. It's called The Great Acceleration. I took it from someone else's paper, Will Stephan's paper. And what it shows you on the left is the socioeconomic trends of our planet. So we've seen a dramatic change, and since probably about the middle of the last century, world population's gone up to 7.5 billion people. It'll probably be 10 billion by the end of the century. We don't exactly know. There's been economic growth. We've seen a dramatic increase in primary energy use in order to manufacture the goods that have been driving the economic growth. We've seen an increase in fertilizer consumption as people are growing more food for this expanding population. Water use is now about 4,000 cubic kilometers, something of that order. I'll come back to that later. And many other things have changed. We've seen tremendous improvements in human health. So since the middle of the last century, life expectancy overall across the planet has increased by about 25 years. And infant mortality has declined, maternal mortality has declined, even absolute poverty has declined. Of course, poverty is still far too many, still nearly 1 billion people, but overall there's been a big decline in absolute poverty. So this has all come at a cost, of course, and the cost has been borne largely by the Earth systems. So this slide, the right side here, shows you some of the changes that are occurring in the systems of our planet, our small planet. You can see carbon dioxide is going up. Now, carbon dioxide is a major greenhouse gas, as we all know. It's gone up to over 400 parts per million. So it started at less than about 270 parts per million. So that's pretty well all really due to human activities. And that's also important because carbon dioxide stays up in the atmosphere for a long time. So when we flying here, the CO2 that the jet put into the atmosphere that brought me here, you know, perhaps 20% of that will still be here in the atmosphere in 1,000 years' time. So that's a legacy that our generation is leaving for other future generations. I won't go into each of these, but some of the things are quite striking. So surface temperature's gone up by about 1 degree overall. The oceans have become more acid. So as you dissolve carbon dioxide into the oceans, of course, it affects the pH of the oceans. They become more acid. We don't know the full impacts of that on the environment, but we do know that, for example, already the shells of shellfish made of calcium are becoming thinner because it's more difficult to form those shells in more acid water. And we know that nitrogen is being poured into water, fresh water, and to the oceans, and that's causing dramatic changes, eutrophication, which results in a lot of loss of biodiversity, sometimes collapse of ecosystems, toxic algal blooms, and so on. And we also know that we're exploiting the land available on the Earth's surface almost to its maximal extent. So we're exploiting a vast amount of the land to grow food, essentially. And this has led, just one other word the word Anthropocene, which I just want to introduce briefly, because most of you probably have heard of the Anthropocene epoch. The term was coined by Paul Crutzen, the Nobel Prize winner, in 2002. I think he first put it in writing. And the reason he called it the Anthropocene was because the global environment is dominated by one species, which is our species, and we are vastly dominating what's happening on the planet. So that's why he called it the Anthropocene. It contrasts with the Holocene. So the Holocene epoch, 11,500 years long. It's when humanity grew up from being hunter-gatherers to agriculturalists and now largely urban population. So the Anthropocene is posing new and as yet not fully understood challenges. This has led to this concept of planetary boundaries. Some of you know about this. Advanced by Will Stephan and others. This is their paper in Science in 2015. And what they said was that there are boundaries, and if humanity can stay within those safe boundaries, then it can flourish, as it largely has over history. But if we breach those boundaries, then it could have all sorts of effects that we don't fully understand. Some of them would be non-linear, so they might happen quite suddenly. Environmental systems may suddenly change, may collapse. And we know that some of these are already being exceeded. So biosphere integrity, genetic diversity, loss of species. We're losing species at more than 100-fold, perhaps even 1,000-fold, we're not quite sure, the rate of species loss that predated human expansion. I've mentioned this flow of nitrogen into aquatic systems and phosphorus as well, ocean acidification, land use change, and climate change, not quite in the red zone yet, but approaching the zone where we're getting seriously worried, the amber zone, when things could start to go wrong. We also know that the responsibility for that is not uniformly distributed. So this is a concept called the ecological footprint, which attempts to measure the environmental impact of different societies. It's a composite measure. It's made up of different things. We could debate whether they got the right things or not, but it's quite a good kind of shorthand measure. And what this shows you is that if everyone was on the planet was to live like the average North American, we would require something like 5 Earths, something of that order, in order to sustain the human population, and Europeans somewhere between 2 and 3 planets. Some of the Asia Pacific and Africa still living within sustainable limits, but that's changing quite rapidly as populations grow and people aspire, of course, to a much higher consumption kind of lifestyle. So this is 2 futures in front of us in terms of climate. On the top line, the red line, is what will happen if we carry on emitting greenhouse gas emissions. It's sort of business as usual, if you like, just carry on pumping them out. And the bottom line is a scenario in which we cut down emissions and keep within the 2-degree limit, which many scientists think we should try to keep within from pre-industrial times. So you might ask, well, where are we now? You know, where are we going? Where are we? Well, the answer is we're somewhere between these two. So if we take into account the Paris Agreement, what nations agreed, their emissions they agreed in Paris, then we're something about 3 degrees, just over 3 degrees warming by the end of the century. But we don't know if those agreements will be honored in the long term. We already know that the US wants to get out of the Paris Treaty. We can come back to that in the discussion. But that's where we are. So we've got no grounds for complacency whatsoever. We are heading towards a potentially risky future. So you might ask, well, what does this have to do with what's happening today? Well, we're already experiencing climate change, of course. But it's also true to say that some of the health effects, the health impacts that we're experiencing today are linked to climate change. And one of those is air pollution. Because much of the air pollutants, or many of the air pollutants that we inhale, are derived from sources which also produce greenhouse gas emissions. So when we burn fossil fuels, we burn coal, we burn oil, when we drive our cars, this produces carbon dioxide, also produces, of course, air pollution. So there is a linkage between the two, and that's both a challenge, but it's also an opportunity, because if we could decarbonize the economy, we could reduce carbon emissions, reduce climate change, but also we could improve human health because of reduced air pollution. So we can see it in both an added threat, but also an opportunity. This just tells us the more detail, some of the linkages between these greenhouse gases and air pollution. So this stuff here is called black carbon. That's the stuff that comes out of the back of diesel vehicles, for example. When you're passing those very heavily polluting buses, the black particles come out, that's black carbon. That's an air pollutant, lasts in the atmosphere only for a few days, but it's important because it's a climate warming. And when it's deposited on ice, snow and ice, it accelerates the melting. So when it goes onto the Himalayas, for example, it accelerates the glacier loss. Methane is another one, lasts for about 12 years. Methane is not damaging to health in itself, but it's a precursor of this stuff called ozone, which many of you have heard of, which is a profoundly oxidative, has a lot of oxidative stress and affects respiratory health, probably causes about 1 million deaths a year, something like that, from air pollution. And methane, of course, is a powerful greenhouse gas, comes from ruminants, comes from rice paddies, and so on. And then we have ozone itself. Carbon dioxide is the long-acting one, which I mentioned. That comes from fossil fuels, a variety of other sources, and sticks around for a long, long time, unfortunately. So the other thing to remember is that when the Earth warms, it doesn't just warm uniformly. The land warms more quickly than the oceans, and parts of the land will warm more quickly than others. So if you look at the Arctic, for example, that is warming very rapidly. And you can see what happens. This is at 1.5 degrees warming. So we could get there within 2 or 3 decades at current rates of warming. We could be at 1.5, something of that order. Some people think we can still avert it. I think, unfortunately, it's very unlikely. So what you can see is that when we reach a global average of 1.5 warming, some parts of the world will have actually warmed by 3 degrees. So it's not uniform. So we're seeing already quite dramatic changes in the Arctic with melting. The other point to make is that people that live in cities, all of us living in cities, we experience a different climate than people that live in the rural areas. When you drive out to the rural areas, you can feel it, can't you? It's cooler out there by 2 or 3 degrees. So it's called the urban heat island effect. And that varies within cities. So depends how many trees you plant, how much water you've got in the cities and so on, and how reflective your buildings are. You can paint roofs with white paint that will reflect and reduce the urban heat island a bit, not very much, but a bit. So the question is, well, what effect might this have on health? And I'm not going to go into great detail. There are whole conferences now on climate change and health, trying to understand the detailed implications of climate change and health. But let me just give you kind of few headline messages that are kind of unfolding on this slide. So we start with the changes in climate, first of all, the rising sea levels from warming of the oceans, the more extreme weather, the rising temperatures and changes in precipitation, the health effect, the effects it has on the mediators of disease, like changes in vectors, disease vectors like mosquitoes, for example, increasing allergens. As you put more carbon dioxide into the atmosphere, you can get growth of allergenic plants, which can cause more upper respiratory allergies, affects the quality and amount of water, can cause water-related diseases, affect food systems, undernutrition, heat-related illnesses and death, and so on. And then this area, which is difficult to quantify, may turn out to be one of the more important areas: forced migration, conflict, and some of the mental health impacts, which I'll mention briefly. So the heat one is interesting. The big heat wave in Europe killed 70,000 people. You might say, well, why did it kill so many people in Europe? You know, they don't get as much heat as, say, we do. And one of the reasons for that is that European society is not well adapted to heat. So when you get a massive heat wave, there's not much air conditioning. This book talked about fatal isolation. It was an analysis of the European heat wave of 2003, 70,000 deaths, excess deaths in the whole of Europe. Many of those people were kind of trapped in high-level apartments, some of them without air conditioning, often elderly, isolated people. Even the care homes, people were dying in the care homes. The other scary thing is that the European summer temperatures for 2003 will become the norm by 2030. So this kind of temperature we thought was really extreme, well, by the 2030s, 2050s, that will be the kind of average summer. We can adapt to some degree. You know, human society has been adapting for a long time, so we can put in place various adaptations, which I'll mention perhaps a little bit later, or you can ask me about. But there's a limit to how much one can adapt. Here in India, for example, you've had your own heat waves, of course. Ahmedabad in 2010 is one quite well-known one. And what you see in these heat waves is the sudden spike in heat-related deaths. So it goes up very, very quickly, often in the elderly population, but also other vulnerable people as well. And since that time, Ahmedabad's put in place a heat wave early warning system to try to give people warnings of those heat waves. The other thing that happens when you heat up the planet is it becomes much more difficult to work. So if you're a subsistence farmer, someone who has to work outdoors, you're not going to be sitting in an air-conditioned tractor. You've got to go out there and earn your daily bread or daily rice or whatever it is. And one of the things we're seeing is that the capacity to work is going down. So this is what we think has already happened since 2000. There's already been a decrease in labor productivity around the planet because of the warming. This is estimated. And this slide just shows you how the warmth spreads. So as the planet moves from recent up to 3 degrees, this area of extreme heat exposure, that you can see it, the yellow, is expanding, growing as the planet warms. And that's the area where it becomes almost impossible to work in the summer months. It's so hot, you can't actually, it's physically almost impossible to work for more than a very short time, certainly without putting yourself at extreme risk of heat stroke. We also know that not just these direct effects, but the climate change and other environmental changes having an effect on crops. So these are the projections for mid-century or so. This is an old UNEP report, but it's still broadly correct, I think. And the red area shows you where crop yields are going to decrease, so much of the tropics and subtropics. The green area where it may increase temporarily, but that's not much consolation to people who've got reduced crop yields. And will people be able to afford to buy food on the global market at that time? We don't know the answer to that. And there's quite an overlap between where people are hungry now and where the crop yield's going to happen. So it could increase undernutrition. And in fact, the most recent data, after many, many years of the prevalence of undernourishment, that's at the bottom is the kind of prevalence, and then the number of people there. So that's been declining for many years, but the most recent data show it's going up. So why is that? Is it climate change? We can't be exactly sure, but it could be. And many people affected in sub-Saharan Africa, for example. It's not just the amount of food, it's also the nutritional quality of food. So as you put carbon dioxide into the atmosphere, it does stimulate growth of some crops, no question about that. These so-called C3 crops, which form some of the plants that we eat. The problem with that is that it also reduces the nutritional quality. So as you put the CO2 up, it reduces the level of iron, Fe, zinc, nitrogen, protein, and increases the level of carbohydrates. So it changes the nutritional balance in the food. And we think that that will exacerbate problems of micronutrient deficiency, which is a very big issue, of course, here in India. This slide just shows you in a kind of graphical form, a visual form, where the per capita burden of disease related to these declines in micronutrients could evolve over the coming decades. And you can see that India is a country which is deemed to be at high risk of reductions, important reductions. We also know that climate and other environmental changes affect fruit and vegetables. Now, fruit and vegetables have been quite neglected, both by the agricultural community, but also the public health community. But we know that fruit and vegetables are very important for human health because they protect against non-communicable diseases, heart disease, stroke, some types of cancer, are all related to low fruit and vegetable consumption. And most of us don't eat enough fruit and vegetables. We need to eat 500 grams a day at least. So some recent work we've done shows that many of these environmental factors, like low water availability, increasing temperature, ozone pollution, all reduce fruit and vegetable production. Carbon dioxide may increase it, but as I say, first of all, it won't be enough to counteract these decreases, and secondly, it may reduce the nutritional quality of fruit and vegetable. As well as climate change, we know that many countries are depleting their fresh water, and that's a real problem here in India. It's a problem in many parts of the world, and the red area shows you where there's very high or extremely high water stress. You can again see India as part of that. So many populations are over-exploiting their fresh water supplies to grow more food. And the problem is that that groundwater cannot be replenished on the human life scales or lifespans. We've done a fair amount of work on the environmental footprint of diets in India compared with European diets and so on. We know that collaborating with a whole range of colleagues here in India, including hopefully in the future, in the very near future, colleagues here in Atri, we know India faces these four interlinked challenges: population growth, dietary change, groundwater depletion, and climate change. So these are kind of interlinking challenges, which will have big implications. We know that a lot of India, including the northwest, large parts of the south, west and east, are over-exploiting fresh water. In some cases, people are using solar pumps, which gets around the problem of fossil fuel energy, but allows people to keep on pumping the water even more rapidly. We do know that overall, some comparison we've done of the environmental impact of European and Indian diets suggests there are differences. So this bar here is the greenhouse gas emissions, so that on average, European diets are responsible for more greenhouse gas emissions than Indian diets, which are quite a lot lower. And the reason for that is because the Europeans tend to eat more animal products, largely anyway. We also know that the green water is the water, it's kind of rainfall. We know that the European diets tend to require more green water, but the difference in the other direction is the blue water. So the blue water is the groundwater. And we know that Indian food systems require more groundwater, partly because of limitations in precipitation and so on. So there are differences in the profile. In the one hand, Indian diets are more sustainable from a climate point of view. On the other hand, from water, there are challenges ahead. Unfortunately, fisheries too are declining. This is a paper looking at global output of fisheries. Now, fish are important for nutrition, Over 2 billion people around the world depend on fish for many of their micronutrients and protein and so on. Generally a very healthy source of food, but it's declining because fisheries are being depleted, largely because of industrial fishing. Again, these fishing boats coming from Japan, from Europe, other parts of the world are, in a sense, sucking the ocean fish. So, well, in summary, the global food system is in many ways unbalanced, and we're seeing a lot of overexploitation of food system, a lot of nutrition-related ill health, under and over nutrition, and many challenges ahead. We also know that rising sea levels will affect more people, perhaps 1.4 billion people by mid-century. And some work we've been doing in Bangladesh shows you how it's also affecting people's freshwater supply. So as the sea level rises, the salt water gets into the aquifers, the coastal aquifers. And this is just some work from Bangladesh. Many of these populations now are drinking very salty water, and that's affecting their blood pressure. So we've studied the blood pressure of pregnant women, but also non-pregnant adults. And we're finding increasing problems of high blood pressure, adverse effects on pregnancy, but also an increased risk of stroke and so on. So this is some work that's still kind of evolving, but does seem quite compelling. We know that India is also quite susceptible to climate extremes like floods and disasters. And this shows you where some of the extent and impact of flood disasters. There's been a very nice report just come out of ICIMOD on the effects of climate change on the Hindu Kush Himalayan region, showing that it's a very vulnerable region to climate change with lots of effects on melting ice and, of course, the major, the Ganges, Brahmaputra. And this is about population displacement. 10 of the large displacement events of 2016 were climate related. Not all climate change related, but climate related, some of them in India. We know that climate change and environmental change more generally also affects mental health, not just physical health. And we've seen increases in mental disorder after floods. There are links between increasing temperatures and suicide rates, and some work in India has also suggested that's true for farmers. And we think that one of the reasons for that is when their crops fail, they're often in debt, they don't know where else to turn, and therefore suicide rates go up. So there may be all sorts of things that we haven't thought about. This is a new concept that I've only just come across recently. It's a very interesting one. It's called Solastalgia. So some of the psychiatrists tell us that people are suffering from grief because their environment is changing so much that what was previously a familiar environment is becoming an unfamiliar one. So they've documented it in Australian farmers. Now their land has turned to dust, and they're suffering from this grief of what was before. And some people in the Arctic are having to move villages because the Arctic ice is melting and their food systems are declining. So they're suffering from this condition of solastalgia, which these psychiatrists have described, environmental grief. Infectious diseases, I won't go into detail. Many infectious diseases affected by climate change. Even in Europe, we're seeing changes in vector-borne diseases distribution. Many of the changes in these infectious diseases are caused by changes in the natural environment and climate. And finally, emerging zoonotic diseases. So these are interesting because these are diseases which are transmitted from animals to humans, and they're often due to changes in land use, food industry change, and agricultural industry change. And one recent interesting example described by my colleagues working in Southeast Asia, they have described a new type of malaria called Plasmodium knowlesi, which is found in macaque monkeys. When you go into the forest to clear the forest for palm oil plantations, the forestry workers come into much closer. They disturb the habitat of the monkeys, and the mosquitoes can transmit the malaria from the monkeys to the humans. And it causes this type of malaria, which has a high mortality rate if it's not quickly captured. So that's enough of the doom and gloom. Let me, just in finishing, try to create a kind of more positive message. In our report, we tried to, we suggested there were 3 issues that we needed to address, 3 broad issues that need to be addressed in order to tackle these problems of the Anthropocene. Whoops, we seem to have lost the, oh, there we are, it's come back again. So the first one of these was what we call, whoops, we're losing connection, I think. So the first one of these was what we called imagination challenges. So we're on that one there. And imagination challenges or conceptual challenges, what we meant was that we need innovative ways, often transdisciplinary research. It means we've got to break out of our comfortable silos where we just talk to the people who do the kind of work that we do. We've got to think more broadly about how we tackle some of these global challenges. And rather than being focused on arbitrary metrics like GDP and worrying whether GDP is increasing, we need to think about, is human welfare increasing? And if so, what impact is it having on the environment, and is it sustainable? So we need to kind of transform the kind of political dialogue. Big, ambitious idea, but we need to be ambitious. Then there was knowledge. You know, we spend, in the health field, we spend billions of dollars on biomedical research, and that's great. My own institution benefits a lot from it, but it's quite narrow. It doesn't consider any of these issues at all. And most of the big funding agencies don't fund research in this area at all. So only recently we've been able to persuade one of the big funders, the Wellcome Trust, to start putting money into this work, trying to understand the links between environmental change and human health. And you can't do it by staying within the health sciences. You have to work with climate scientists, with agricultural scientists, with engineers, with energy experts, water and sanitation people, urban planners. You know, it's a totally different ballgame than the kind of traditional research that we used to do. But it's very exciting at the same time. The third area is implementation. Even when we know what to do, we often don't do it. And the reasons for that are complex. We discuss them later. But let's face it, there are big vested interests who are not going to change easily. You know, I think many of us thought we could have a rational debate about this, but we're seeing that in the States, for example, there's a big pushback. There's science denialism, there's climate change denialism, and that's being fermented. It's not happening by accident. There are reasons for that, and the reasons are there are powerful interests who are stirring up doubts. And I'm not talking about uncertainty. Uncertainty is fine. We all deal with uncertainty. Science is about reducing uncertainty. So there's no problem with skepticism, but denialism, a frank refusal to look at the evidence, that's a problem. So let me quickly move very quickly to some of the potential solutions. One of them is the health system itself. So the health system has an impact on the environment. Greenhouse gas emissions in the US is about 10% of greenhouse gas emissions are linked to the health system. The energy to run hospitals, they're very energy hungry. Also, we know that pharmaceuticals are very energy intensive to make, and medical equipment. So we know that we have to reduce the environmental footprint of the health system and also create more resilient health systems that can cope with environmental change. And we need to build new hospitals that are much more environmentally sustainable. And this is a nice new children's hospital that's come out, which is, you can't hardly see it actually, it looks like a park, doesn't it? But actually there's a hospital under there. They've put green roofs. And they asked the children, it's a children's hospital, what kind of hospital do you want? And the children said, when we're sick, we look out of our windows, we want to see green. And when we're feeling better, we can play, we want to go outside and play in the green with our parents. So that's what they did. They had a car park there. They closed the car park, got rid of it. I don't know if there was a lot of complaint, probably there was, but they overcame that. And they created this great hospital, which is very energy efficient because it's half buried underground. And it's a green hospital and people can use this as a kind of park. So it's an interesting example. We need to decarbonize the energy system. This is a paper just coming out next week from the Proceedings of the National Academy of Sciences, where we've worked with a group of atmospheric chemists to try to model the likely benefits from reduced air pollution if we could decarbonize the energy system. And so the atmospheric chemistry models then show us where the benefits are greatest. You can see here in India, it's about 3.6 million deaths a year we could prevent potentially, reduced air pollution. And India, probably about 1 million a year, something of that order. So that's from reduced air pollution, because air pollution is such a big killer. It kills us from heart disease, cancer, stroke. It's a major risk factor. And even more if we could reduce other sources. These are the fossil fuels, and these are the total human emissions, including agriculture and other domestic energy. So these are some other things we can do, reduce some of these sources of pollution that I mentioned, the big smoking diesels, clean fuel, the brick kilns and so on. We're also seeing a lot of action at the city level. So many cities are increasingly seeing themselves as sustainable cities. This is a small city in Finland that's aiming to be it's aiming to be completely zero CO2 by 2050, zero waste, and seeing waste as an asset. So instead of throwing things away, we have to accept more and more that there's a lot of embedded energy. You know, it's now possible to mine more gold and precious metals out of mobile phones, old mobile phones, than it is by going into a gold mine. So per gram of material, you're going to get more money out of people throwing away their mobile phones. That's more valuable than going underground and mining. So, you know, that's an interesting example of how a kind of circular economy could help us to, you know, we've dug up an enormous amount of resources, we just throw it away, we waste it. So we need to think of it as a kind of resource. We're seeing a lot of innovations in urban environments, car-free zones, bus rapid transit, car sharing, bike sharing, and so on. So they're sort of taking off around the world. Still not enough, but it's beginning to happen. There's a lot of health benefits from more sustainable travel. I won't go into in detail, but we did some work with Delhi some years ago showing that through more physical activity and reduced air pollution, you could reduce heart disease and many of these other common problems, including diabetes and so on, by more sustainable transport strategies. I don't know if we'd find the same numbers if we did it today. It's a different situation, but certainly there'd still be benefits. And then green space. So there's a lot of interest now in the effects of green space on health, right? So there's a lot of evidence around mental health. There's some work on mental health. It's a meta-analysis of multiple studies. This is the no effect line here, and this is the benefit. So it reduces displeasurable moods and increases pleasurable moods, exposure to green space. We don't fully understand why, but we believe that being exposed, having that opportunity to go out into green space, to see green space, to use it, somehow improves our mental health. Even physical health. This is a study from Canada in 2 million adults, and you can see there's a link. This is a satellite measurement. So people are now linking satellite images of green with human health. So this is a satellite. They use satellite images of green, so-called vegetation index, and they link that to health, the risk of heart disease, and it goes down as people are exposed to more of this green space in close proximity to their home. Again, we don't know quite the mechanism. Is it reduced air pollution? Is it increased physical activity? Is it because of better mental health? We're not sure. We also know that many cities need to restore their ecosystems, for example, to protect fresh water. So many cities get their fresh water from protected areas, about a third of big cities. And so they need to protect those areas in order to sustain their clean water. And we also know that ecosystem natural solutions can help to protect against floods. So for example, wetlands and so on. It's been suggested that if New Orleans had been protected, if they hadn't degraded their wetlands, then the storm that they had, the hurricane, wouldn't have caused so much damage. And it's because they'd neglected or they destroyed a lot of their wetlands. And also you see it with its tsunami protection as well. Housing, a lot of interest now. This is a small project in Delhi, which is trying to look at healthy housing. It's called OptiHouse, because it tries to optimize housing for health in poor communities. So what it tries to do is to, instead of looking at one thing in isolation, it's trying to optimize approaches to damp and mold, heat and cold by better ventilation, better insulation, reduced ingress of disease-carrying mosquitoes, reduce indoor air pollution by more clean energy, and reduce ingress of pests. So what they're trying to do is to look at an integrated approach to urban design, to housing design, which maximizes the health gain for obviously at a very constrained budget. And then finally, the food system. Just a few moments on that. What's striking about the dysfunctional global food system is that we waste so much. So 30% of the world's total agricultural land is used to produce food that's never eaten, just thrown away. And there are different reasons for that around the world. Some of it's destroyed in the field. Some of it's thrown away after eating because people buy too much, they don't look after it. So reducing waste is important. And also we know that Western diets consume far too much animal products because which have big environmental impacts. So vegetarian diets can reduce greenhouse gas emissions land use and water use as well. And even moving just towards a healthy diet helps to do that at a lower level. And some of you may have seen this in the press over just of recent weeks. This is called the Eat Lancet Commission, another one of these Lancet commissions. I commend it. I wasn't involved, but I think it's an interesting commission. And what they tried to do was to develop what they called a planetary health diet. So it was a diet that would sustain the human population at a much lower level of environmental impact. And what they said was we all ought to eat more fruit and vegetables. So we eat enough, 500 grams, including green vegetables. When we eat carbohydrates, we need to eat whole grain cereals, not refined cereals. Red meat here, particularly red meat, should be consumed in very small amounts on a global level. More nuts and seeds, and less sugar, of course, as well. So they mapped out this kind of what they called the planetary health diet. Some people said it wasn't kind of culturally attuned enough to different cultural needs, but what they were trying to do was give us the kind of big picture, and I think they succeeded in that quite well. So finally then, in conclusion, what we need to do in order to secure planetary health is to put health at the center of our economy. And you know the Sustainable Development Goals, of course, there's one on health, which is largely about health care, which of course is very important. But health is more than health care. So we need to address poverty, hunger, better education, gender equality, clean water, clean energy, sustainable cities, and climate change in order to secure human health. So in future, we need to broaden our scope from just thinking about health care and treatment to thinking about a more holistic approach to health, which sets health within the context of our small planet and our need to develop within these planetary boundaries. So let me leave you on a positive note. Of course, there are many, many challenges. You know, how are we going to cope with a global population of could be 10, could be 11 billion people by the end of the century? On the other hand, we already have quite a lot of knowledge. We know a lot of things that we should do and could do. We also have a lot of rapidly emerging technologies which can help us in the food system and the energy system. We need to capitalize on those. But probably most importantly, we need to think about values. We need to think about human values and what are we really aiming for? Are we just blindly rushing ahead with economic growth and consumerism? Or do we have values which put health and environmental protection at the center of our society? And my view is that we're not going to tackle this with technology alone. You need the right values in order to accompany that technology in order for us to sustain human health and environmental health, in other words, planetary health, in the Anthropocene epoch. Thank you very much.
Thank you, Professor Haynes. We have some time for questions now, if you don't mind.
No, not at all. Not at all. No, absolutely happy.
So if the floor is open and there are a few mics I can pass around.
Thank you so much.
Try that one.
Maybe we can just talk without mics. It's a small room. Yeah?
It's a small room. I can probably.
Yes. Okay, for the video.
Video. Yeah. Okay. Yeah.
All right.
Yep.
It's a good talk. I appreciate it. I would have expected to see the planetary health impacted by the human. Its impact on the microbial part of the planet.
Yeah.
How they are together connected in affecting the entire biosphere.
Mm-hmm.
Microbial aspect, where there is large percentage of planetary carbon is kind of there.
Mm-hmm.
You want to comment
Yeah, no,
on
that's a very important point. You know, I could not be comprehensive. You know, otherwise I would have kept you here all evening. And also, I'm not a soil scientist, but I do accept, of course, the importance of microbial activity. And we're seeing, as you say, profound changes in microbial activity. Of course, we know that soils are being degraded in many parts of the world. Probably 12 million hectares a year of soil is being lost, with a lot of microbial ecosystems within them being lost. We're also seeing transformation of the human microbiome. So we're understanding more about what goes on inside us. We have this internal environment, and increasingly people, biomedical scientists, are looking at the relationship between the bacteria we carry in our gut, in our intestine, and human health. We're beginning to understand more about that. So you're absolutely right. The microbiome is crucial. We're also seeing that there's a lot of antimicrobial resistance spreading in the environment because of the inappropriate use of antibiotics by the medical profession, but also very widely used in the food system. So many poultry, I was talking to colleagues in Tamil Nadu, they say a lot of the poultry that they eat, they're using antibiotics as growth promoters, and that of course will increase antibiotic resistance. And we're even seeing, if you look at the water coming out of the factories that make antibiotics, you find a high level of antibiotic-resistant bacteria in the water coming out of those factories. And so that is another way in which it's spreading around the planet. So yes, there are profound links, and we also know that the bacteria in the soil, for example, as you say, are very important for fixing carbon. And so if we destroy them, then the soil can't take up the carbon to the same degree. So yeah, I mean, I don't pretend to be an expert in that area, but I think I recognize the great importance of it. And I think you're absolutely right to raise it as a...
Generally, in climate conversation,
Yeah,
this linkage,
yeah,
the microbes, how they basically, basic factories are run by them
yes,
on the planet.
yeah, yeah,
We are only byproducts
yes,
of the basic factories run by the microbes.
yeah.
But we don't pay as much attention as it deserves.
Yeah, well, I think what you've signaled is a very important area for both research, but also maybe we in the health community need to understand more about the importance of soil microbes in terms of maintaining the environment. Thank you.
Thank you very much, Dr. Hayes. Can you hear me?
Yeah.
Thank you very much for such an enlightening talk and the nobility of your human values. Because I always brood over and ponder over the lack of human values in education. Forget about the illiterate, even the educated are somewhat illiterate about human values. So coming to the point, we as humans have been here 1 inch of 1 kilometer
Yeah,
of the age of the earth and how quickly we are trying to destroy everything. How else can we influence geopolitical leaders and corporates? That instant profits are not enough. And even though we are able to go into outer space commercially, all of us now, it's not enough for our children and grandchildren. So how can we influence the world, leaders and all other professionals and governments and simple people and citizens, that instant profit is not the way, but to think globally, to act locally, to think of the future and love
yeah.
the trees which we are always cutting.
Well, of course, what you've raised is the key challenge, and I don't presume to have a simple answer to it. If we had a simple answer, we wouldn't be in the position that we're in. And I think there are two slightly different issues here. How do we influence politicians, and how do we influence the private sector? The private sector is interesting because there are some businesses that are seeing their business model as sustainability. So we're seeing a number of businesses that are actually modeling their projections for the future on the Sustainable Development Goals. You know, you see progressive businesses like Unilever and so on are beginning to think in those terms. And you're seeing a new economy coming up around sustainable energy, a lot of innovation in food systems and so on. So they, in a sense, they would, if they were here in this room, I don't know if there are any of them here, but they would be kind of understanding what we're talking about and would probably be broadly on the same side. We're also seeing businesses that are moving towards the circular economy. So they're thinking about how to exploit waste. There are growing businesses around exploiting e-waste and so on, and just moving it around the economy rather than just throwing things away. So things are changing quite dramatically, but there are also private enterprises which have based their business model on a very profligate consumerism. and burning of lots of fossil fuels. And what you're seeing in the States at the moment is it's the fight back of those people. So it's the fossil fuel industry is fighting back. If you asked me a few years ago, I would have said there was a possibility of engaging them in a more productive discussion. You know, BP was talking about being beyond petroleum. After a couple of years, they forgot that, and they're now fully back in petroleum again. Of course, they make a few nice asides. They say, well, of course, we're quite interested in green energy. We put a tiny proportion into green energy just to keep you green people, you know, quiet, but it's not a serious, commitment. So, unfortunately, it does look as though the fossil fuel industry is not going to go away easily. And therefore, increasingly, we have to confront them, I'm afraid. It's a bit like in the public health community, we had the tobacco industry, you know, so we're quite used to their kind of machinations and their devious tricks and so on. And, it's the same, I'm afraid, with the fossil fuel industry. Ultimately, they have to be confronted and you have to face them down as much as you can. Not going to be easy, of course. And the problem is that the business model we have at the moment is based on businesses not paying the full economic cost of their activities. So if you're a coal company, you're not going to pay the full economic cost of your coal mine. You're not going to pay all that pollution you put in the local rivers, the fly ash that contaminates the environment, the CO2 you put in the atmosphere, the air pollution, the mercury. You're not going to pay the full economic cost of that. Your whole business model is based on not paying the full economic costs. And so you're going to resist any attempt to regulate you and to get you to pay the full economic cost. So I think the argument is that we're being shortchanged by these people. The only reason they're able to continue as they are is because they're going to damage our health and the health of future generations. And they need to be regulated because they don't want to be regulated. And the only way to do that is by increasing the political will for regulation. And you are seeing, some political leaders are prepared to do that. Some are not. Some are trying to dismantle regulation. So ultimately, it's a question of trying to work with those who are at least convertible, if you like, to that kind of way of thinking. And we're also finding a lot of more inspired leadership at the subnational level. So some of the mayors, if you look at the governor of California, the ex-governor Jerry Brown. So Jerry Brown was talking about they're going to decarbonize their economy, whatever happens to the rest of the US. And that's 20% of the US economy. So the Californians are going to do it anyway. And in the end, it's going to be really difficult for a country like the US to buck the trend because who are they going to sell the technology to? People don't want to buy it anymore. We want to buy clean, efficient, renewable technologies. So that has to be a big hope. It's the subnational level leaders. And where we have them, of course, progressive national leaders, we have to work with them. So it's a long drawn out, there's no simple answer. We could spend days discussing how to do it. I think the other issue for optimism is the young people. So in my own country, we're seeing, I've mentioned it already to Mahesh Chandra and others, but I think it's an interesting movement. So we've got these young children, 15-year-old kids standing outside school, started by a young Scandinavian woman. And what they're saying is, well, you adults have messed the world up. You're leaving us a polluted planet. And in fact, the motto is, if you adults won't behave like adults, we will. So I think it's good. Some people criticize them. I think that's what we need, We need young people to shame the adults into doing something. So all power to them.
There was a time when the Rockefeller Foundation had made a series of programs on, how the Rockefeller Foundation, a series of programs for telecast on media.
Yeah, I think it's okay.
Anyway, on media. And they were being appreciated by children here, And then the government got upset as to who the hell is this Rockefeller Foundation. And then so one of the nastiest industrialists in this country decided to go and partner with Murdoch.
Yes.
And now the Star Network is beaming nothing but animals killing each other on that same channel.
Yes.
That was once showing us, how flowers would survive or how the landscape was changing and things like that. So what has happened is, sadly, that one of the pillars that could have been used has now completely been taken over for the propaganda and for maybe you people have been able to be a little bit better off than us in a way because you have maybe a smaller population to deal with. And
we have Murdoch as well, I'm afraid. He's doing a lot of damage where I come from, I can tell you.
Yeah, but Murdoch wasn't partnered by somebody without a conscience. Maybe surreptitiously or subconsciously he was being able to succeed. And so we were actually having some, and despite all my efforts to even appeal to the R&D ministry and people, it was just too the hell are you and how dare you? And,
Yeah.
So what I'm trying to say is that somewhere along the line, you should just try to be a little bit more invasive and allow meaningful programs to come back for people to see that.
No, I agree with that. I mean, it's not easy to struggle against these powerful interests, but we do have other people on the other side, people like David Attenborough, who does these wonderful programs that do get beamed around the world. And Al, yeah.
You know what did they do? They decided to criticize Pachauri. Arey Baba, doesn't matter if Pachauri has a slightly, strange side to him or something like that. In terms of at least, putting our carbon points at 90, we were the second highest, very rich. At that time, carbon points were trading at 80 and 90.
Yeah.
You must have a conscience, as you said.
So yeah, it's an uphill struggle working with the media, but we have to keep trying. We have to get better at communicating, I think, with the media. I mean, as scientists, we're not always, we weren't trained in kind of communication to the public. Sometimes we're not always very good or very clear and so on. So we need to engage, more popular meetings, also social media. I mean, we're not very good on, at least I'm no good on social media, but I mean, a lot of my younger colleagues are really quite active on social media. So that has a lot of impact too. So no simple answer, keep on going and work with the progressive forces in the media where you can find them.
I'll take one last question and then we'll move on to the next part of the program. I think Dina,
Thank you.
You lost your time. You put your hand, are you okay?
So thank you for sharing. This is something that has been there since long. I feel that there is this notion that the other needs to do it, like the government needs to do it, or the corporates need to do it. And we fail to see how we are contributing. And I feel that at an individual level, how is it that I change? Like, I know, I am aware that I'm contributing to the air pollution. How am I changing? So I think I could connect to what you said, values. And in India, I think we really connected to our values, to our roots. However, we're forgetting to practice. So I think just bringing that attention to really practice is the need. So
yeah, I mean, I fully agree with you. I mean, obviously, ultimately, we do need to go down to the individual level, because once people stop demanding things that are not necessary, I mean, it's obviously consumer demand that's driving quite a lot of this. And when we become less materialistic ourselves, then we diminish the impact on the environment. When we change our diets, when we don't drive so much or whatever, so these individual behaviors do have an effect. At the same time, you need change at all levels, because one individual, or even this, if we could all change simultaneously, it would have a limited impact. So we also need to think about the broader structural determinants of this and how we can influence them. So I'm all in favor of individual change, but I think we need to have different levels of change. We also need to have a political analysis and we need to tackle some of these broader issues as well. So we need to move on all fronts. We are seeing some quite encouraging kind of individual changes in behavior. So in my own country, for example, we've seen a tremendous growth in kind of vegetarianism amongst young people and so on. Completely voluntary. I mean, nobody's been pushing it. It's just it's happened by social media and so on. A lot of young people doing that. Also seeing a decline in car ownership in the UK. I'm not happening in India, but it's happening in quite a few countries. And young people not even bothering with a driving license, because if you live in a city, you don't really need to drive a car in general, in many cities anyway. So we're seeing that also happening in many countries. So there do seem to be some changes happening at the individual level. It's not always easy to find out why, but they're happening. And they're probably transmitted through social media. They become new social norms. And then it becomes not so cool to be very ostentatious. And, it's not such a cool thing to be. So that's good. I applaud that.
Thank you very much. And thank you for joining the panel. We'll move on to the second part of this program, where we'll raise many of these issues that Professor Haynes has raised. and maybe expand on them through some new ideas and maybe just explore some new directions in there. I would like to. But I'd like to first invite Professor Darshan Shankar to join us. Professor Shankar is currently the Vice Chancellor of the University of Transdisciplinary Health Sciences and Technology, known as TDU for short. He has coordinated national level programs in several fields in order to demonstrate the contemporary relevance of India's medical heritage. The core fields include national policy formulations for traditional medicine, in situ conservation of medicinal plants, development of traditional knowledge databases of medicinal botanicals, theoretical foundations of Ayurveda, scientific validation of traditional health practices, and promotion of ethnomedicine. He has written one book, chapters in several books, and peer-reviewed articles. He has also won several national and international awards, including the Norman Borlaug Award, the Columbia University's Center for Complementary and Alternative Medicine's International Award for Cultural Stewardship, and the Government of India has conferred upon him the Civilian Award of Padma Shri. Our next panelist I'd like to invite is Dr. Professor Vijay Tandru. Vijay Tandru had his formal training as a decision scientist after obtaining his PhD from MIT. His academic career in teaching and research in computational mathematics was at Purdue University and the Indian Institute of Science. He's a fellow of the Indian Academies of Engineering and Science. Chandru has research and policy interests in precision medicine, digital heritage, and digital epidemiology. As a technology entrepreneur, he was one of the inventors of the Simputer and currently serves as the chairman of Strand Life Sciences, both of which are spin-offs from IISc. He was named the Technology Pioneer of the World Economic Forum in 2007. He serves on the Vision Group State Council for Biotechnology and Science and Technology in Karnataka. Lastly, I would like to invite Dr. Veena Srinivasan. She's a senior fellow at the Ashoka Trust for Research in Ecology and Environment, Bangalore, where she leads the Water, Land and Society program. Veena received her PhD from Stanford University's Emmett Interdisciplinary Program in Environment and Resources. Veena's research interests include social and environmental innovation, citizen science, and sustainable water management policy. Veena has won several awards for her research and is the current shareholder of the prestigious Prins Claus Chair in Netherlands from 2018 to 2020. Veena was recently appointed to the Strategic Advisory Group of the Task Force on Monitoring SDG 6 by UN Quarter. So I would like to, the format for this panel discussion, which I have the onerous task of moderating, is that I will invite each of the panelists, other than, of course, Professor Hayes, because we just heard him speak, for 5 minutes to give us an introduction to their areas of expertise and how it relates to planetary health. So I'll invite Dr. Veena first.
Thanks so much, Abhi. So I think I was really intrigued by the topic when you announced it, because I think this is something that we all struggle in our day-to-day life, in the sense, particularly at ATRI, where we work at the intersection of environment and development. The Water Health and the Water, Land and Society program at ATRI is part of ATRI's Center for Environment and Development, which particularly looks at how do we make development gains without impacting or having serious deleterious effects on the environment. And so this is something that we focus a lot of our research on. And I'll start with the obvious link between the environment and water and sanitation, which is the history of sanitation itself. And I think it's been argued that sanitation, the development of sanitation as a technology has been the single largest contributor to improvements in life expectancy. And in fact, the very first epidemiologist, if I understand correctly, is still considered to be John Snow, who with his early work in on cholera detection, basically made the argument that you need to separate your water systems from your sanitation systems. And it's been argued, I don't know how many people here have heard the story, but there was a cholera epidemic around the mid-18th century in London. And what he realized he was a medical practitioner, and from what he realized from looking at cholera cases was that they could all be linked to specific hand pumps. And at that time, the germ theory was not understood, the germ theory of disease. And what he really was able to establish was the link between specific wells and the sewage or the wastewater which was being dumped into the wells and the disease that it was resulting in. And he was able to trace back. And he's also considered to be one of the earliest or the first GIS people, the first person who mapped disease on a map without a computer, of course. And so I think that obviously from the water and sanitation sector, the link between the environment and the need to separate out sanitation and clean drinking water has been very, very clear. And it has been enshrined in the Millennium Development Goals and the goal for access to water and sanitation. Now, I think what has become clear over time when we transition from the Millennium Development Goals to the Sustainable Development Goals is that it's a lot more complex than we thought. So initially the push has been, let's just get people access to an improved drinking water source, let's get people a toilet, and that should be sufficient separation of your safe drinking water and sanitation. And I think my own colleagues from Planetary, Priyanka and Durbai here, so I'll call out to them, have shown that a lot of that has actually led to problems. So contamination of groundwater. More recently, people have started seeing antimicrobial resistance in wastewater treatment plants, particularly where basically everybody's antibiotics through your gut is basically entering the same wastewater treatment plant, and that's leading to emergence of antimicrobial resistance. So I think what we are seeing is consistently in the process of achieving some of the basic development goals, we're slipping back in other ways because when new threats are emerging as we fail to look at the system beyond and for 200 years, I think water and sanitation has been very much civil engineering. And I think now we are kind of seeing all kinds of emerging threats because of that. So another example, I mean, you talked a lot about nutrition, and I think that's another excellent example because a lot of the work that we're seeing, I mean, I work particularly on groundwater. And one of the biggest impacts that the Green Revolution has had is to pull millions of Indian farmers out of poverty. And along with that, improve basically nutritional levels, people moving from growing rain-fed ragi or rain-fed millets to growing vegetables and fruits. But that very investment in improving nutrition and improving access to fruits and vegetables, which you showed as part of a healthy, sustainable diet, has also led to groundwater depletion. And then that groundwater depletion is then causing slippage in drinking water because a lot of rural India depends on drinking water, which is borewell-based drinking water. And so basically in the pursuit of improved nutrition and higher income for farmers, we're basically causing groundwater depletion, which is then causing us to lose access to drinking water. So I think, I can keep going on and on about similar examples, but I think basically I would like to say broadly, there are many, many such linkages, whether we look through groundwater depletion, whether we look through what's happening with sanitation and nitrate contamination or antimicrobial resistance, or whether we look at the spread of malaria and dengue fever as part of improperly done sanitation in cities. I think all of these are basically, we're seeing the same kind of trend, which is we're trying, it feels like a treadmill that we have to run faster and faster to stay in the same place. And I think that this is something that really then suggests, and that's why we really appreciate the talk about how do we break down silos and how do we then start looking at it in a more integrative fashion. Thanks.
Thank you so much, Veena. I'm going to jump over you, Zanu, and go to Darshan first. Then I'll come to you last. Reasons.
This is a complex situation in which we are in. There are complex reasons why we are in that situation, and some of them have been outlined by Professor Elaine. And in healthcare, we say, there are certain diseases which are of a degenerative type. And in a degenerative disease condition, you can slow down, the rate of degeneration. It's very difficult to reverse the condition. Perhaps we are in a situation like that in the context of the health of the planet. And while, therefore, we have to be looking at solutions based on what Professor Elaine outlined as imagination and conceptual imagination and knowledge and implementation and so on and so forth, I think we need to look at some of these things beyond the kind of knowledge systems that we have been actually using. A lot of the development that is going on in the last 200 years is largely based on Western cultural intellectual traditions. And that's fine in the place where it originated. But those traditions of the Western cultural intellectual traditions have really, penetrated into countries with very, very rich cultures, with very, very rich knowledge traditions of their own. And all of these have got eclipsed. And if you look at our university systems, it's absurd for a country like India with its rich heritage and across so many domains of knowledge to be, right from school to formal university, have categories of knowledge, which are all based on something that is coming from outside. We don't want to make this big thing about inside and outside. The world is one and, we can learn from everywhere. But when you have your own, traditions, your own knowledge, it is suicidal to ignore it. And so that's the context in which I'm going to say a few things in relation to planetary health. We have in the university a database on the knowledge that people have about medicinal plants that exist in India. And we are talking about a large number of species which are distributed across all ecosystems. We're talking of something of the order of 6,500 species, and there may be more. These are the only ones that have been actually documented. So in the university, we have a database of the 6,500 species, their geographical distribution, and the associated knowledge that is related to these species. Now, you can see that you can look at a situation of universal health coverage, not in terms of the debates that are going on how to improve the current health system, but by really building up on ecosystem-specific plant resources and their associated knowledge. You can find solutions to a whole lot of primary health care. You can find solutions for food and nutrition. There are so many resources in ecosystems that have not been documented in any texts of modern nutrition. You can see resources that can be used for animal health, for veterinary, livestock health. You can see plants that can be used for organic agriculture itself. So just to give you a very quick example, so many of us here, Indians, you would have heard of a plant called Brahmi. And you can look at traditional knowledge of Brahmi, 1500 BC. And it says Brahmi is Smriti Prada. Smriti Prada means it will enhance memory. Now, we've been working with the National Center for Biological Sciences, and they have been looking at Brahmi. And they were initially skeptical, and they said, we don't know whether what was said in 1500 BC is really true or no. my grandfather believed it, and so on and so forth. And then there have been experiments done, animal experiments, experiments on proper biological models of cognition. And what you do find is that indeed, Brahmi, if you look at the hippocampus, you can see molecular changes, you can see synapses being formed, and there's absolutely no doubt that Brahmi enhances memory. For the last almost 10 years, we've been working with dairy farmers, across the country. And more recently, the National Dairy Development Board has taken interest. And mastitis, for example, is a very common disease of cows, and it occurs all over the world. It cuts down milk production. It leads to antibiotic resistance because the treatment involves the use of antibiotics, and they get in food chain. Now I was just a few weeks ago at a conference that at the National Dairy Development Board, where milk dairy unions right from Punjab to Kerala reported how they had used a very simple, traditional formulation based on this traditional knowledge that I'm talking about. It really consists of just aloe vera and turmeric and lime or something in a particular proportion. And they brought down the cost of treating a mastitis-infected cow from 3,000 rupees per cow to 50 rupees. And the outcome was increased from around 20 to 30% to over 90%. So, these are just examples I'm giving you. Or we are, plagued with this whole issue of iron deficiency anemia. You can see that for decades we have been pumping our population and households, giving free even iron folic acid tablets, and that hasn't brought down iron deficiency anemia in the country at all. It has remained more or less at the same level as it was a couple of decades ago. And we've been doing experiments in our laboratory on Kakadu cell lines where iron absorption takes place, and we have shown that you feed that cell line with iron folic acid, iron absorption is that much. You add vitamin C, the absorption goes up a little bit, but you add a herb that is known and easily available all over, the fruit called amla, the crude extract, it goes up 3 to 4 times. And this is well known in traditional knowledge that if you want to increase bioavailability, bioassimilation, then use amla. If you add amla into your diet, you will find if you can put it into a mass food, just like we've put iodine into salt, if you can put this into a mass food, you will find that iron absorption from the food that people normally eat will go up. So there are lots of solutions that are available on, and this need not be universal solutions. What I'm talking about is ecosystem-specific solutions. Every ecosystem must be having, never mind whether it is Rajasthan, whether it's the Trans-Himalayas, whether it is tropical, temperate, you'll find anywhere from between 150 to 500 species that are ecosystem specific. And if you understand those species in the light of Indian medical heritage, you will find solutions for human health, for livestock health, and for organic agriculture. Now we really need to build on this kind of cultural resource that we have in this country. Not look for solutions for planetary health only based on solutions derived from Western cultural intellectual traditions. I'm not decrying them. They have their strengths, they have their limitations. And so do our knowledge systems have their strengths and limitations. But we need to expand this thing. We stop having solutions for planetary health being derived from one cultural intellectual tradition. The world, we need multicultural solutions. We need universities to create these kinds of databases. We need to create laboratories for transdisciplinary research. Here, what I mean by transdisciplinary research is cross-cultural research. In Indian context, we're talking of Ayurveda and biology. Ayurveda and biology is a systemic approach, which is what our knowledge systems are about. They have a systemic understanding about changes that take place in biological systems. Unlike modern science, which has structural changes that take place. So you know what is happening at the part level, at the molecular level, you don't know what's happening at the whole level. Here is the other way around. We know what's happening at the whole level, at the systemic level. We have no clue at what's happening at the molecule. When you combine these kinds of knowledge systems, you develop very powerful platforms. You need omics for that. You will need to, integrate. You will need a lot of information technology. So that's all I'm saying as an introduction.
Thank you. That's fascinating. As the applause will tell you, and it allows me. Thank you. It allows me to segue very well to Chandru's areas of expertise. Please.
Sure. So, as was already mentioned in the introduction that Abhi did, I'm basically a data scientist. I'm a electrical engineer and computer scientist. One of the things that really strikes me about the types of topics that we've been talking about is how the world is driven by eminence-based policy rather than evidence-based policy. Right? So it's really true that if the data could be out there, if the evidence can be presented, then why shouldn't we make more rational choices, right? So I think the role of the modern data scientist is really now to democratize, to organize data in ways in which everyone can understand, and understand when people are pulling wool over their eyes, right? And trying to talk about the right things to do when they're not the right things to do, right? Whether it is focusing on GDP as the measure of well-being, or a happiness index, or whatever, right? So, well, what do I do about all this? I teach a course at the Indian Institute of Science on digital epidemiology, and so I'm trying to get young people to understand how to manipulate data to create this type of evidence that can be used for understanding the spread of disease, the control of disease, and so on. And the fascinating thing is that now, particularly in the last 10 years or so, we are in this epoch of what we call the second half of the chessboard, as far as information science and data science is concerned. Basically, Moore's law entered the second half of the chessboard roughly around 2006, 2007, right? So we have seen this incredible acceleration of our ability to process information. And so today, for example, there is an organization called AIME, which does artificial intelligence-based epidemiology, which is starting to be able to predict maybe 3 months in advance the possibility of epidemics, like a dengue epidemic and so on. So one of the students in my class got very excited about this and said she'd do her thesis on predicting dengue in the region here, and we just couldn't find the data, right? So finally she wrote her thesis on Singapore because we could get the data for Singapore. So I think one of the big challenges that we have is to actually be better at archival, better at putting the evidence together, or the data together, so then we can get to the evidence bases. At Strand, of course, we've been on the biomedical side of data science applied to genomics, and today, of course, that's an impactful area. But I just want to bring up again this whole business of what the evidence actually says, right? Now, when it was mentioned that I'm been involved with the World Economic Forum, so I was actually a member of the Global Alliance for the Future of Health at the World Economic Forum between 2014 and 16. And we decided to focus on misalignments which are affecting sort of poor health policies, right? And so we took precision medicine, which today, we understand as being able to analyze omics and address an individual and prescribe based on individual characteristics. And now, if that were to be used instead of today, it's largely used for treating cancer, maybe some rare Mendelian disorders that people are, children are born with, more for diagnosis than for treatment. In cancer, it's actually used for treatment. But suppose we were to use it for chronic diseases. What is the evidence now? And so, fortunately, the RAND Corporation has actually built a simulation model for the US health. They call it the Health Innovation Simulator, THEMIS. And so we ran, THEMIS was run on the scenario of, can precision medicine make an impact on chronic disease, cardiovascular disease, lung, respiratory diseases, and so on. And you could, according to the simulation, it's very clear the economic impact of preventive health in chronic diseases using precision medicine would be enormous. And the US economy would really benefit from it. The health economics says that. But you can't do that because of the vested interests of pharmaceutical companies, of the insurance sector, and the way healthcare works. So actually, the work cut out for data scientists and modelers and so on is actually a very intriguing role. I mean, right through Sir Hain's talk, we saw incredible sophistication in data analytics that was showing up in all the graphs, the plots, the visualizations that he showed. So I think there's a, again, just like we need to take a more holistic view of transdisciplinary sciences, I think we also need to get much more involved in this aspect of evidence-based understanding rather than eminence-based understanding.
Is it eminence or finance?
I think to a large extent, yeah. The vested interests of various kinds.
Great, thank you. So I'll start with a quick question to you, Sir Haynes, about one of the graphs that you, or one of the figures that you showed about from the Lancet EAT commission, which sort of has it's because I'll keep the focus to India in particular because of our location, but as you yourself pointed out, that there was some criticism of it being culturally or not having cultural sensitivity, because it was, it came from a very Western perspective, that palette of what is considered to be a healthy diet. There's been some talk also of how when in countries in Asia as well as in many African countries, where there is actually you have the opposite problem of lack of nutrition. Should you first think about bringing up, using all resources possible to bring up nutrition levels so that you have a more equitable distribution of nutrition, and let the more Western countries worry about reducing obesity and having more healthy diets. Let's just bring it up to basic human studies, part of the SDG goals, and so on. Your comments on that, please. And how you think that ties in with sustainability itself?
Yeah, thanks. I mean, I wasn't directly involved in the Lancet Commission, and I wouldn't necessarily defend everything they did. But I think, all these big global analyses can never give you the kind of fine-grained information you need. They should be seen as an attempt to model or assess in a simplified way a kind of global system. I think they got quite a lot of criticism, I know, from the Ethiopians, for example, which were one of the Ethiopian ministers spoke out and said, well, actually we need to increase animal product consumption for the nutrition of children. Now, whether that was correct or not, that was what the Ethiopian perception was, that you in the West are trying to dictate to us some kind of dietary norm which may not be appropriate. And that was why I gave that cautionary note. I think what they were doing was full of good intentions in a way. They were trying to outline, and they were trying to focus very much on adult health, I think, rather than child health. And we do know that non-communicable diseases are the major affliction of adults. Even in lower middle-income countries, they're coming up. So to some extent, I think you're inevitably going to get criticism when you try these very large kind of global assessments and modeling exercises, because they're never going to be fine-grained enough. And maybe we shouldn't be expecting that, because I think what should happen is that each country should look at these kind of issues themselves and say, now, what would make sense in our context? How could we maximize the health through improved diet at the lowest possible environmental footprint? So I think it's more a kind of wake-up call, really, for individual countries or even regions, because a country like India is so diverse, for example. You couldn't have, again, if you tried to do a single Indian diet, you'd also come up with the same criticism. You're not being sensitive to the different cultures within India. So it needs to go down to the kind of appropriate geographical level. But I think what's good about these big, ambitious global commissions is that they stimulate debate, and they make people think about it, and they make people even disagree, and that's good, because it makes them go back and reflect how we might do it better in our context. So from that point of view, I think it's worth doing, even though it's a flawed exercise. But no, I mean, I'm obviously very convinced by the fact that you need to translate this into reality at the local level ultimately. And we need to challenge people as to how best to interpret some of these pressing issues through the lens of local beliefs and local culture. But we have to start somewhere. And, it's partly a way of provoking, I think, a debate and a discussion.
Thank you. Do you have a comment?
Yeah, I want to actually respond. I mean, I actually want to ask a question more than, because they're clearly, very experienced panel here. So what I heard from Vijay Chandru and Darshan Shankar was what in our field we call the Newton versus Darwin debate. I don't know if this same framing is used in other fields as well. But the Newtonian approach is basically considered to be the mechanistic approach, which is really basically saying that you can make predictions if you've seen something before and developed a model for it, which is what I think the AI kind of tools do very well for. Or if you want to use a Rumsfeldian kind of matrix, then I would call them the unknown knowns, in the sense that they're known, it's embedded in your training data sets, and so an AI algorithm can get at them. But I think what Darshan Shankar was talking about was really what in our field we call the Darwinian approach, which is that certain signatures or systems emerge because of coevolution of communities in the environment. And I'm coming from watershed hydrology, but that's it's a different analogy, but similar. And I think we've struggled in the field of water to kind of reconcile these, because on water, on one hand, you look at systems and you say these have co-evolved from long histories, which is where Darshan Shankar came from. But then we try to put them into models which work as long as your data or what you've measured or your mechanistic model, but it won't predict the unknown unknowns, so things that you have not yet encountered. And I think one of the struggles is how do you reconcile these? And so I don't have an answer, but I think since I have two eminent panelists, I can ask a question.
Okay, if I can just take a crack at that, I think, that's somewhat a narrow definition of what is happening with predictive systems. Have you heard of AlphaZero? Okay, so there's also unsupervised learning, where it's not based on training sets, but programs have been learning how to play games and beat world champions without even being told the rules of the game, right? So it started out with DeepMind in the UK, which built, AlphaGo, and now it's Google is, of course, bought it. so it's now part of a program called AlphaZero. So I think, it's not. I think there's both the Newtonian and the Darwinian approaches that are coming into play here. But I also think that one should be careful about the overuse of things like artificial intelligence systems and all the ethical issues associated with it. But I think you shouldn't underestimate what it's capable of. I think and that's why people are nervous about what it can end up doing. So, by the way, there was an article today that I read that said that they did a huge survey and people would much rather believe AI than politicians. This was in Spain.
I'd just like to make really an side sort of a comment on the nutrition side that you raised. That we are aware that at least in a country like India, and I think recent A3 survey has shown, for example, that in a particular location, the people are aware of a whole lot of edible vegetables and fruits, a large number, something of the order of 100 plus species that don't come into the marketplace and that have been consumed by people. I think that in this whole area of nutrition, there are two things that need to be looked into. That the science of nutrition as it stands today is, at least in the contemporary, is fairly incomplete. In the sense we rely on food chemistry. So we know the composition of the food in terms of calories, proteins, etc., all of which is in vitro. And we don't know what is going to happen to it when you actually consume it. Each body will respond to that food differently. And here omics and so on and so forth can come into play. If you're really going to, you need to know the genotype of the person who is consuming that food. His entire metabolic calibration will be very different from that of another. And we have very little understanding. In the whole area of food, we know food chemistry, we know very little nutrition, we know very little customization to, what we call nutrigenomics. And so we are on a very, 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 gross sort of thing. That's just a side comment.
I'll actually take your side comment and push it a little further now. So you had mentioned to me while we were chatting earlier about food is medicine, and that entire field, because ultimately I suppose a lot of the traditional knowledge systems practice this, and it was about eating the right kinds of food at the right times. You also said something very important. You said ecosystem specific solutions or plants that are available in certain areas and people have sort of adapted to use them. In our current situation, where most of our ecosystems are facing massive degradation or pressure from various development schemes, how sustainable do you see this kind of utilization going forward? So if we had to say, no, let's combine these and let's move it forward, how do you see this progressing given the massive challenges that we face in conserving our natural resources and these systems that were there?
I don't know. I guess it will vary according to, the different types of ecosystems to the extent to which they are relatively undisturbed or to their degree of current disturbance. It would depend on that. I mean, something that has been wiped out kind of a thing would be difficult. But we are actually been experimenting with oasis kind of projects. I mean, I don't know how oasis, when I say, I mean, an oasis in a desert, we don't know how much you can scale this up. But you can look at ecosystem resources, document them, and there will be resources that are, food, and some that can be used in chronic conditions or more as medicine, some in that interface between food and medicine, but a lot of resources, you can use food itself as medicine, and this is based on a knowledge system. It's very expensive to do your genotyping. Lots of people can make a lot of money out of that. But there have been papers recently shown that in the traditional knowledge, we have in 20-25 minutes, we can do phenotyping. We can find out your phenotype. And there are papers now published in Nature which are showing the correlation between the phenotype and the genotype. And the phenotype doesn't require sequencing and all that kind of a thing. So you can, so one is you got to look at your local resources. Two is you have these methods of phenotyping a population, which corresponds to their genotypes. And if you know your genotype or phenotype, then you can adapt your diet and your lifestyle suited to your requirement. Now, this is part of the general comment that I made, that, if we are looking for solutions to the complex problems that we are facing, let's not look at those solutions only from one particular intellectual and cultural tradition. The Africans may be having something, the Chinese may be having something. India certainly has a very, very, very rich heritage in terms of health sciences. And of course, we must use tools. I am all for using the tools of data sciences and so on and so forth, with only one sort of a caution that, the tools will interpret the data, but the data itself needs to be looked at very carefully. In my view, modern pharmacology itself is a very flawed area, because you are got all your bioassays, be they in vitro, be they in vivo. Let us estimate to what extent do they actually mimic the biology. You're fragmented. You take them out of context, and what is happening on that cell line is what's happening on the cell line. But that cell line in the real biological system is linked up with a whole lot of other things, and so it's very fragmented data that forms experimental pharmacology. It's very fragmented, and it's become as a surprise to some of you. It's very fragmented approach that even forms clinical pharmacology. If you come to my hospital, the university has a hospital. So now you look at, we have treated, let's say, 200 cases of Parkinson's as diagnosed in terms of ICD. Now you look at our case records, you'll find that the treatment is varying for those 200 cases. And you say, why? Don't you have a standard treatment? The condition is the same. And we say it's not the same, because what you are calling a homogeneous group in a clinical study is to us a heterogeneous group, because there are variables which you haven't taken into account. Those are variables which at the frontiers of biology we are realizing. The genotype, the intensity of the disease, the kind of physiological perturbation that may happen. We have terms for this in traditional knowledge. You can find modern biomarkers for all of these, and you'll detect those variations. And therefore, what you are calling a homogeneous group is actually a heterogeneous group, and you're applying a standard treatment for a heterogeneous group. And that's why your outcomes are what they are. I'm just making.
On that point, again, India is becoming more and more urbanized. At the same time, we are facing a crisis of primary health care for the poorest. This is a question I think that how do you find solutions to integrate these systems so that, because one of the things we really want to focus on is the equitable distribution of resources, so that the people who are the most vulnerable to all of these changes, environmental changes, for very little of which they're responsible for in many cases. How do we translate, or how do we bring solutions to these problems by integrating or by looking at different ways? Any takes on this?
Well, I mean, you're absolutely right that primary care is essential. And what we find is that many governments are prepared to put very large sums of money into tertiary care, but neglect the primary care basis. And so what you end up doing is treating diseases which could have been prevented if there had been an effective primary care system. We're also seeing a medicalization of people, so that people without necessarily a defined disease, but they may have symptoms, they may feel ill, they may have somatic symptoms of distress, are then given a label of a disease and are treated with pharmacological treatments, which has its own adverse effects, of course, and also labels them as being ill, when in fact what they may be doing is somatizing some distress within their personal life, related to relationships or economic situation and so on. And this kind of more holistic perspective is really flourishes, I think, much more in an effective primary care system than it does when you reach kind of secondary, tertiary care, when people are tended to be put, at least in a conventional system, into diagnostic boxes and diagnostic categories. So, of course, it's important to make a diagnosis, but it's also important to accept that in primary care settings, you see people with undifferentiated symptoms. Some of those may go on to develop defined diseases. Some of them, as I say, may have non-specific symptoms, which may even get better spontaneously as whatever was causing that disruption in their life resolves. Some may get better with some psychological support and relatively simple kind of interventions. And it seems to me that policymakers are in a sense bewitched by the temples of disease, which obviously I visit, I work in myself, but at the same time, although I accept that you need this kind of care, at the same time, if it dominates the health system, it distorts it, then you end up by spending vast amounts of money for very little return. So it's a question of designing the most appropriate health system, which is right for the society in which it's based. But certainly, I think in all societies, the primary care system needs to be the basis of that. And I know, for example, in India, the primary care system, in my experience and talking to people, is quite weak and fragmented. And is often seen as a very low prestige part of the health system which you need people with the least training. Actually, anyone who's worked in a primary care setting, particularly in a rural setting where you're on your own, knows that it takes the highest level of intellectual ability to try and deal with these kind of very difficult problems without backup. It's much easier, and I've done it myself as a trainee. If you're working in a nice tertiary care hospital, patients come to you, they have a nice diagnosis, you have super specialists on hand who can tell you what to do. To be honest, intellectually, it's much easier than working in an isolated primary care facility when you don't know what's going to come through the door, and you don't know whether you're going to have to deal with a dramatic emergency or whether you're going to have to deal with some if you like, almost existential issue, which someone wants their advice about. So, I think we've got the pyramid the wrong. It needs to be inverted. And we need to say primary care is the basis. This is what we should be training people for. You actually need good training to be a primary care worker, whether it's a doctor or a community health worker. And you can't do it with a single person. It needs to be a team approach. And it's only by having the right team with the right balance of community health workers, of nurses, of doctors, that you can actually get the best results. And we haven't spent enough energy and resources on developing that strategy, which has to be based on the kind of local community and what their needs are.
Thank you. So I was just going to localize this a little bit to the Indian context. I think the broader question of equity in health care, I think we have a fundamental flaw in our policies today. The fundamental flaw is that I do not understand why healthcare has not been declared as a fundamental human right. In our constitution, it's only a directive principle. It is not a fundamental right. Now, a few years back, we corrected that in education because the middle class sort of demanded it, right? But healthcare hasn't been actually declared as a fundamental right. We talk all around it. You know, there's Ayushman Bharat and all kinds of strange, ways in which we are approaching the issue of universal healthcare. But I think fundamentally, if India does not declare health as a fundamental right, I do not see a big change happening, right? I just want to talk about two sectors within the Indian population that are hugely under-resourced, right? One sector is the elderly. And last week we had a conference on aging in India at ISAC. And there's by the way, you would love this, Darshan. There's 75,000 elderly people in India now being followed longitudinally, and phenotypic data has been collected. It's being done by the Indian Institute of Population Studies, and the data will be made public. So there will be an ability to analyze. They're spending about 4 to 6 hours with each individual to collect this phenotypic data. So I think this is being done all over India. It's being funded by the Ministry of Health with participation from the National Institute of Aging at NIH, right? And Harvard School of Public Health is the other PI in this. But what is emerging from all of this is how hugely under-resourced and underserved the elderly are, right? The other group that I want to mention is, Ravi Chalam is here, and we run the MetaString Foundation, which, as many of you know, has been working on the India Biodiversity Portal. But the other portal that we run is for rare diseases, right? And India, because of its practices of endogamy and so on, actually has an extraordinary number of, people with rare diseases, where it's probably around 50 million or maybe more, right? We just don't have the full registries today, right? Whether you think of thalassemia or hemophilia or sickle cell disease, or, they're in the hundreds of thousands. They're not small numbers in India, right? And for these people, healthcare has to be coordinated healthcare, right? And so it's not, as you were pointing out, it has to be a team approach, and primary healthcare for them has to be a very coordinated approach. And that's again that's a lacuna that we have today, and we need to address. But I think all of these get addressed if you address that fundamental issue of universal healthcare. I think, look at China today. I think they're spending 6 to 8% of their GDP on health. The combination of primary, tertiary, and their use of traditional medicine is fantastic, right? When I fell ill at visiting Chengdu at the Tsinghua University, walked into the hospital, right side allopathy, left side traditional medicine, and traditional medicine took care of me, right? There's really no, it's a level playing field there. They have done it so well there. Right? So anyway.
How would you scale this?
No, I think that I completely agree with both of them. But I would only say that we need to, in particularly countries like India or parts of Asia, Africa, even South America, we really need to also invest in non-institutionalized healthcare as a right or whatever. But I think that 30% of primary healthcare problems can be taken care of, and I'm not speculating. I mean, this is the tradition of this region, Asia, Africa, South America. We were treating dysentery, diarrheas, preventing of malarias cough, cold, non-specific fevers, simple gynecological problems with locally available ecosystem-specific resources. I mean, we are working now, Ravi is also involved in this, Ravi Chelam, working on a portal to give information on ecosystem-specific resources, citizens portal which will carry reliable information on their uses for human, livestock, and for agriculture. Now, we can validate, we can revalidate this, we can, do clinical studies, preclinical studies, use the right platforms of Ayurveda biology and all that to strengthen our conviction about the value of this. But I think we need to conceive of a concept, what I call the fourth tier. The three tiers, primary, secondary, tertiary, this is institutional. I think the home itself is a provider, and we have taken away that knowledge. We have disempowered millions of homes all over the world, who were managing considerable part of primary health care with centuries of valuable knowledge. I think we need to revive that in a future scenario, particularly of something like planetary health. We have to reduce the dependence on institutions and, health in your own hands kind of a thing. I'm not saying it can do 100%, but 30% is a lot.
I'm just going to change tack a little bit, step back, and ask again a question to all the panelists about the link between. So when you look at all those maps that you show of India, it's unfortunately a glowing beacon of danger. It shows up red, all these, on every global map of threat, India shows up red, glowing. And the three that we've seen here are, one is climate vulnerability, water, and health. And yes, the sort of there are trade-offs between mitigating that. There's not a linear, at least from some of the discussions we've had, there doesn't seem to be a linear relationship between if you solve one problem, all the other problems also get solved. There are trade-offs. For example, between carbon sequestration and water. How do we try and address some of these issues? And this will be the last sort of thing because but then I'll bring us to closing remarks.
I think we have to accept that. I do believe that as we get more health data out there, as I was saying, the evidence comes out, we will begin to understand how sick we are as a nation, and I think hopefully that will scare people and the policymakers into maybe doing more to control things. The trends are good in the sense that at least we are beginning to monitor stuff, right? I think for example, the whole sentinel sites that ICMR has set up now around the country to monitor viral infections is starting to actually work. I mean, if you think about how the Nipah crisis was nipped in the bud, that actually happened because the health authorities very quickly reached out to Dr. Arun Kumar at Manipal. He recognized that it was the Nipah. Even before the National Institute of Virology could actually confirm it, he hinted to them that they needed to start containment processes. And that's why in Kerala they were able to contain it, right? So things are getting put in place. I think air quality is being monitored. I think most of us read that column in the newspaper every morning, right? And we know if we are traveling, and going to Delhi what we need to do, right, to stay safe. So I think, knowledge is power. And I think as we become more knowledgeable about what we are doing to our country and ourselves, I think hopefully we'll act a little more rationally. Right?
Say something and I'll let you wrap up. So I was really, I was really intrigued when Sir Andy Haynes showed the health SDG 3 with all the other SDGs, because every SDG sector that I've seen has theirs in the center and then all other things. And I think the thing is that, but still, when I look at just SDG 6 alone, the only people who actually come to the meetings are, and I've said this before, not even broad water sector people. Mostly it's just water and sun. I mean, it's really been hard, even within the water sector, to get everybody together. And Lancet really needs to be complimented for the incredible job they've done with the Lancet Eat and Lancet Climate. I mean, really, really outstanding work. And I think institutions, so data is important and knowledge is important, and we've talked about that, but I think institutions also, we kind of need to think about how creative ways in which we get different people at the table, and we're not actually doing that at the moment. We're still kind of siloed by sector. I don't have an easy solution, but I think talking about it helps, because then at least then we remember when we're calling a meeting, let's call 3 other people. So.
Well, I mean, I think I'm certainly not the right person to talk about solutions for India, but if I could just offer 1 or 2 reflections. I had an interesting experience in Delhi. I was walking up the Lodi Road with my wife, and we saw this air pollution monitor, and it said PM 2.566, and I thought, well, that's quite high. Yeah. And then next to it was green. And I was thinking, well, if in London it would be red, So I was thinking, well, it depends how you perceive things so much. And we need to increase people's ambitions. So, we should be talking about green should be well below 10, actually, because even at 10, we know that air pollution is causing damage. So we need to increase people's aspirations. And also we know that politicians don't like difficult problems where they have to confront powerful interests, and air pollution is one example of that. And they also have to confront people who want to drive their cars, whatever, and it's difficult for them. So we need to, I think, in the health and the broader, by health I mean everyone who's concerned about health and sustainability, not the healthcare professions. We need to work together more to kind of raise the ambition that the public should be demanding better quality of the environment, and demanding that their children and vulnerable older people and so on are less exposed to these damaging environments. So it's by raising our game, raising our level of ambition, I think, and the public will start to get mobilized. We're even seeing, and we have much lower levels of air pollution than here, but because we know it causes adverse effects, the public are beginning to get concerned. So you're now getting parents outside the schools talking to other parents saying, I don't want you to see you letting your diesel 4x4, idling outside this school, because my children are going to this school and they're getting affected by the pollution. So these people are going to be much more effective at changing behavior than we are, just by giving these broad messages. So mobilizing the public is really important. And I think also mobilizing younger people, because they use social media so much better than most of us in the room. And I think they're also much more energized by things like data. So, getting younger people, not just the scientists, but also the arts and humanities, who are much better at communicating these kind of issues in a very exciting way than we in the science community are. So, I think it's something everyone is needed and everyone is welcome to try and address these big issues, because unless we try to mobilize the whole of society, we're not going to have an impact. So we need to think about carefully how we can do that. And that's partly culturally related, but there's also an international dimension of this. I think young people seeing themselves much more of an international community. They communicate internationally. They even have friends they've never met. They've just met them in cyberspace. So that's something we should capitalize, or they can capitalize on more. So whilst the challenges that face us are great, also I think we do have potential solutions that we haven't fully explored. And I think data can be powerful, and the way in which we use data can be very powerful.
Any questions from the audience?
What happens to organic food? Why is it costing us more? The pesticide content is less. Why is it? You go to new trust for organic
organic produce, but why is it becoming out of reach for the man who should be able to afford it and enjoy it?
Any takers for this question?
I think it's something to do with demand and supply. No, I'm just saying it's something to do with demand and supply. There's not enough supply, I think, that's what the problem is. That
Will it come down if the supply increases? Will the price
No, what I mean is there's not enough
or is
people
it because
growing.
it's being marketed in such a fancy way now?
Also, but there are lots of us who want that kind of food, but it's not available, to that extent. And therefore, the people are exploiting that situation with prices and so on.
I think it's also a good example of how we don't pay the full economic costs of things. So the pesticide industry doesn't actually pay the full economic cost of all the impact of the insecticides and pesticides on ecosystems. So we are subsidizing them actually, and that's why organic food is costing a bit more, because it doesn't have those kind of subsidies. It also doesn't have the research and development. So all the R&D has gone in, or most of the R&D has gone into conventional agriculture. Very little spent on organic agriculture. If we spend more, we could increase yields, I think, much, much greater.
I just want to make one comment. It appears that all the problems of climate change and lack of biodiversity, loss of wildlife, deforestation and excessive carbon is due to the lack of scientists yelling and hollering during the past 60 years to the leaders and the public and the citizens that we're going the wrong way. We have to change now. We have to think of creative, holistic, integrated solutions, which we haven't. Now we have to only retrofit. Perhaps we've come too far. I don't know about 1.5 degrees centigrade increase, but that we can control that. Because everybody wants development, especially the emerging economies like India and China. And nobody's interested in long-term, high investment cost for clean energy and sustainable growth. And I just had one comment on Dr. Darshan. I think Ayurveda, in my opinion, is very holistic and integrated because it does not see the human being in an Anthropocene way. That you're a separate head of the ladder of the human, of the animal evolution, and therefore you can control, you eat this, you don't eat this. You see yourself as a part of the plant life. You see that your body and the plant life are similar. And you consume food as a form of medicine. I think that's a very, very intuitive, very progressive concept. So I think we need creative retrofitting solutions to reduce the population and the carbon footprint, not only of both global corporates, but of every one of us. Thank you. Questions?
Yeah, I don't know if it's a question or an observation, but you mentioned about, eminence versus evidence-based. So isn't that a cultural bias too? Because when you're talking of evidence-based, you're talking of a number-based. Evidence has to be numerical. And can evidence not be experiential, which comes to that side of maybe traditional forms of medicine or food or lifestyle? So that is one thing.
Something deeper along the line you are speaking about, because this is complete nonsense. This polarity between tradition and modernity is total nonsense. There is no such thing. Every society evolves from its own roots. Every society. European modernization is revitalization of classical Greek tradition. They had a dark period there and so on and so forth. It is a sociological myth that tradition and modernity lie on two ends of the spectrum. The roots of your present lie in your past. And the past, present, future lie on a continuum. So we need to, thinking-wise in academics and so on and so forth, correct our understanding of modernity that this is traditional, this is modern, and two ends of the spectrum. It's not the case. Modernity can only happen from its own roots. And in a society which loses that connection, it is a case of colonized minds. It is a case of imposition. Not to say that we remain insular and say, look, I will only follow my own traditions and build on my own tradition. I want to have nothing to do with the rest of the world. But when you discard your own, I mean, it's not just medicine. You see it in agriculture, you see it in mathematics, you see it in logic. I mean, you look at, Chandru may have known this particular scientist, Raja Ramanna, who many of you would have known. And, I happened to be his neighbor for years together, and so we were friends despite our age. And, in his 70s, one time, the two of us were talking, and he said, Darshan, I have started reading Indian logic, and I find it more sophisticated than all the logic I studied in my physics. And he was at the frontiers of physics. He says that Aristotelian and post-Aristotelian logic is 2 valued. This is 5 valued. So, I mean, this whole business of tradition, modernity and all is a colonial, misunderstanding that was created, for political reasons. And, we have to get over that.
One last question.
Actually, let me just quickly respond to the numbers. So I wasn't trying to say that evidence has to be only numerical and quantitative, right? So today, sentiment analysis, text analysis, qualitative analysis is very much part of what you would do.
Okay, yeah, very quickly. Since today's talk is about both the environment as well as public health, and a common observation is that veganism is now trending on Twitter and Instagram, which is a good thing. It saves the animals, protects the environment and all that. But do you think 10 years down the line, your data scientist friend will bring you a graph showing a dip in B12 levels, or are you confident that wouldn't happen? People are educated enough to take supplements.
I'm not a panelist.
No.
I am strong views.
Is it advisable to follow the trend?
No, I mean, the problem is that there are often unintended adverse consequences of acts which are done with good intentions. And veganism could be one of them. It depends whether people are aware of the lack of the need for extra B12 or not. So we found it quite often even in climate change mitigation. So about 7 or 8 years ago, the then government was promoting diesel vehicles over petrol vehicles because of their lower carbon dioxide emissions. And several of us said, don't do that, it's going to be bad for health. Obviously, the diesel industry is very powerful. So they got their way and they were incentivized through subsidies. It was a big disaster, it was a mistake. And it made the air pollution problems worse. The point I'm trying to make is that whenever you make an action, you need to think about what the potential unintended adverse consequences might be. You start with very good intentions, but unless you think through, and we're dealing with systems here. This is the important thing, is we're not dealing with simple linear cause and effect. We're dealing with systems. When you perturb systems, then they can do all sorts of unexpected non-linear kind of things. So what's important is to think through the implications of what you're proposing, how it might perturb the overall system in which it's operating, and whether that could have unintended consequences. And the veganism thing is a good example. I mean, if you look at some cultures that promote very strict veganism, for example, in the Caribbean, we have Rastafarians who promote very strict veganism amongst their children. And we sometimes see amongst them rickets and other vitamin deficiencies. So you need to understand that people at different parts of their life may have different nutritional needs, and where there are nutritional requirements, then they have to be part of the overall package.
So I'm just gonna put all of you on the spot for the last time and say that if you wanted to leave this audience with 2 key messages, what would they be? Just distill everything that we've said, just 2, because people need to have tweetable.
Also, one tweet. One person has to tweet.
1 tweet, fine. Not even 2, 1 tweet.
My message has been repeatedly said that broaden the base of knowledge, and make it multicultural. Don't rely on one single cultural intellectual tradition.
That's brilliant.
Health is a fundamental right.
Excellent.
I thought you'd say something about data. I'll say bring different stakeholders to the table because otherwise you're going to miss linkages that you might not see.
Well, to simplify grossly, if we are the problem, then we're also the solution.
Excellent. I would like to very quickly thank all the panelists. I think we've had an excellent discussion. Of course, I'd like to first thank Professor Andy Haynes for that really amazing lecture. I'd like to thank the British Council for hosting us very graciously. And the Indian Academy of Sciences for bringing in Sir Andy Haynes all the way from the UK. And I'd like to thank my colleagues from A3. And we have a small token of appreciation for the panel. I'd like to invite Dominic to. Yeah. This is for Andy Haynes. I hope you're spacing the language. For Vina.
You want to all stand there and take a picture?
You can open it if you like. It's a book. Yes. Thank you.
Thank you very much.
Thank you very much. There tea and a picture. Yeah, pictures. Yes, picture.
Please.
I will be on the edge.
Yes. Thank you. Tea and biscuits are served outside, so please come in.